or morning, depending on where you're joining us from today. My name is Bob Pollack. I'm a transportation specialist with the FHWA's Office of Safety. I'm also a member of the data and analysis team within the Office of Safety, and I'll be serving as your moderator for today's Geospatial Transportation Mapping Association webinar, which is entitled Improved Asset Management Practices, Finding Roadside Hardware Types. Today's topic is especially important and timely. State and local transportation agencies are constantly working to improve how they collect and manage roadway assets. From a safety perspective, the better and the more complete an asset inventory, the better it lends itself to use in making decisions about the safety of roadways. Provisions in the latest transportation legislation, that is the Moving Ahead for Progress in the 21st Century, or MAP 21, encourages states to create an inventory of roadside assets. This legislation also identifies capabilities that states are expected to have within their state safety data systems, and one of those capabilities is the ability to integrate diverse sets of safety data. And for our purposes, we define safety data as crashes, roadway characteristics, and traffic volumes, which allows states to develop predictions for the safety of any given road segment, intersection, or interchange. Now, to do this, states need to have high-quality roadway inventory data, which includes roadside hardware. I think today's webinar will present an excellent example of how this type of inventory can be an asset to a state DOT. Now, regarding today's webinar, it's going to focus on how the Utah Department of Transportation used their network asset data collection project to locate and prioritize and upgrade Texas Turndown guardrails. And let me introduce today's presenters. They're a couple of friends of mine. They are from the Utah DOT. Stan Burns is the Director of Asset Management, and Scott Jones is the Utah DOT's Safety Programs Engineer. Little background on Scott and Stan. Stan holds a BSCE degree from the University of Utah. He's a registered professional engineer with 25 years of experience. During his career, he's held positions in design, operations, planning, and program management. Scott is a licensed professional engineer and professional traffic operations engineer. Scott administers the federal and state safety initiatives and programs, including the Highway Safety Improvement Program for Utah. Now, finally, before we begin today's presentation, let me take care of one piece of housekeeping. There will be opportunities for you to ask questions of the presenters during today's webinar using either the chat or question box feature. So if you would, simply type your question in via the question or chat box section of the GoToWebinar control panel. And after our presenters have completed their presentation, we'll get as many of your questions as possible. And with that, Stan, I will turn the time over to you and let you go ahead with your presentation.
Thanks for the introduction, Bob. I appreciate it. And thank you to GTMA for giving Utah Department of Transportation this opportunity today. So the title is, as you can see, Improved Asset Management Practices, Finding Roadside Hardware Types. We have a few slides, and then we have a few tools that will show you, time permitting. So I'll give you a little bit of an idea of Utah. We're a fairly small state, as you can see. We only have 2.9 million people, fairly large state. The DOT here is responsible for, you can see that, about 6,000 centerline miles, 16,000 lane miles, and we're a relatively small state again on the number of full-time employees we have. I show you this slide because we've been able to do a lot of interesting projects over the last several years, from design build to accelerated bridge construction to our U-plan, U-gate. And one of the reasons why we're so successful is because we're small, we're nimble, and I know that other states have challenges they're so much bigger than us, and their systems are so much more complicated. But just throw that out as a caveat. We don't mean to boast. We have a fairly easy job because our system is so small. Bob mentioned that we have a fairly robust inventory of what we have. In 2012, we went out to contract, and the purpose of the contract was to collect as much of the data that you can see above ground, right-of-way fence to right-of-way fence. So we drove the entire state system, both directions. You can see the number of centerline miles and 14,000 driven miles. But one of the most impressive parts of this program was that we had all of these groups at UDOT in together on this project. So maintenance, traffic and safety, and the division that I work for, asset management, were the primary funders of this program, but we also had structures, GIS, IT, motor carriers, pre-construction, right-of-way, regions, programming, and traffic operations. And so when I speak with other DOTs, I say this is probably the most impressive slide. Instead of collecting it many, many times with many different groups of DOT, we all joined forces. We came up with common dictionary, common wording, and had one contractor collect everything from fence post to fence post. So what does that mean? The contractor drove, and every 26 feet they took these high-definition images, which I'll show you later on, stitched them together. That's over 7,000 images stitched together, and you can see the resolution, 2400 by 3200. And everything was geospatially located, and that's really critical because visually, if you can show on a map where your guardrail is, where your substandard guardrail is, the offset of that guardrail, it's just much more easy. It's easier to visualize it than looking at spreadsheets, one after another after another. So to give you an idea of what I'm talking about, here's a typical roadway. This is I-250 in Salt Lake Valley. We geospatially located every sign. But not only that, the attributes we captured were the width of this sign, the height, the MUTCD code, the lettering, the background color, and the condition, good, fair, poor. We located every single support, the type of support, the offset, barriers. Here we're showing guardrail and Jersey barrier, but we also did cable barrier. Again, the location, the height above ground, the end section, the end treatment, walls. Here it's just a retaining wall, but we did noise walls, MSE walls, bin walls, all geospatial located. Lane, not only, these are HPMS lane designation, but we also have the width of these lanes and the type of material. Is it concrete or asphalt? Shoulders, the same thing, the width of the shoulders, the type of materials. All striping. Here you can see here the solid, the skip, the inside, the outside lines, and these are all geospatially located. This is an image of down by Moab, but rumble strips, surface areas. This is the way we categorize how many square yards of concrete or asphalt or interstate concrete, interstate asphalt, or rural two-lane roads. We also at the same time did pavement distress surveys. So here we're just showing automated detection of cracks, but we also had rutting, faulting, falling, raveling, where there's crack seal, where there's not crack seal, potholes, medians, the type of median. Was it concrete? Was it a mode? What's the width? Geometry, horizontal, vertical. And then in Utah, it's very important to know elevation. Elevation in Utah is anything from 2,000 feet above sea level to our roads go up, I think, to 11,000 feet. So that's important for wintertime operations and also summer operations. Is it too hot to place that concrete, as an example? Is it typical intersections? We noted all intersections, all curb cuts, pavement markings, messages. You can see we're locating on this one, bikes and arrows, but we did all kinds of favorite messages. Geospatially located again, bike lanes, drainage, whether it's in the curb, out in the roadway, islands. Here we have curb type, but we have a curb and gutter. Signal cabinets, and then signal poles, 5-section head, 3-section heads. And then lastly, all manholes, monuments, valves. And so it's a complete inventory, and we completed that in 2012. We did the second collection cycle, 2014, and we've located all of this information in our maintenance management system that then pulls nightly into our ArcGIS U-Plan U-Gate, geospatially locating all of these features. And I think the next slide is Scott's, but let's see, it is. So I'm going to go back. So I'm going to tell you a story. Now, I showed you all of these assets that we collected, but then the next challenge for Scott and I is to educate as many people in UDOT what we have, and then have them start using this in their business processes. So Bob mentioned that we're going to talk about Texas turndowns. We do have Texas turndowns in the state of Utah, and I'll show you a picture of this shortly. We do have a specific program that we are replacing those Texas turndowns. So our director wanted to know the progress of how we were doing to replace Texas turndowns. We allocated money through the commission. They approved it. And wasn't happy with the progress because we couldn't tell him our progress. And of course that got a lot of people's, he got quite concerned. That got a lot of people concerned also. So his staff said, we'll just have our maintenance folks go drive those roads. And piece of paper and clipboard, and I think I'm at milepost 6.7, and luckily my boss, who's one of the senior leaders, said, oh, wait a minute, I think Scott and Stan have this information because we've collected it the last 2012, 2014. Let's have them show us where all the Texas turndowns are in the state. So we had somebody on our staff, a young millennial engineer who's out of school the last 5 years, and I've just pulled this spreadsheet into the screen that hopefully everybody can see, and I will expand it. And so what this list is, down here in the bottom left-hand corner are region 1, 2, 3, and 4. We are 4 regions in the state of Utah, and we're looking at region 4 right now, and we are looking at all the locations with Texas turndowns and concrete slope end sections. Those were also a problem. And I'm scrolling slowly to get to the bottom of this spreadsheet. But to get to the bottom of the spreadsheet, I have to go all the way down to 436. So we took our data from our asset management system, and we pulled from that all the Texas turndowns and all the concrete slopes in the entire state. And so I've just showed you over 400 in Region 4, which is the southern part of the state, Texas turndowns or concrete slope that may be a problem. So what we did then is I'm using my mouse to circle the top right column AM and AN, and you can hopefully see AM, which is AADT. So we pulled from our geospatial database and linked it to our Texas turndowns and concrete slope end sections, the ADT for that specific section of road. And we also pulled from our asset management database the speed on those sections of road. And we knew that because we collected, remember I told you we collected everything above ground from fence post to fence post. Well, we have approximately 105,000 signs. So we were able to query out of that all our speed limit signs. So we merged several sets of data. And I'll just show you, this is the route, column B. So here's State Route 6, the various mileposts, the starting and beginning end of a concrete slope, Road 2, and you have to jump down here to State Road 9, which is row 36. You can see milepost 48.7 to 48.79. There's a Texas Turndown. And in this particular case, it's inside the clear zone. So by determining the offset of that Texas Turndown from the travelway, the speed of that travelway, and the ADT, we told the region it's inside the clear zone, or if you look down this column to my mouse, hopefully, you'll see outside the clear zone, row 48. So outside the clear zone, they didn't have to replace it. So to give you an example, let's go to this row 45. It says we have a Texas Turndown. It's inside the clear zone because it's only 5.3 feet off the travelway. And you can see the speed limit. So if I were to right-click on this, we have linked the images. Remember I told you we took images, 3 images every 26 feet, high-definition images. So we linked those images. We queried those images from our ArcGIS system. And you can see there's the Texas Turndown right here. And if I step back one slide, we'll see another Texas Turndown right here. So this is, in 2012, we had a problem with Texas Turndowns in that area of the roadway. So I'm going to go back to this same spreadsheet now, and I'm just going to do a right-click on it. And it's the same section of road, but it's 2 years hence. It's 2014 collection. And if I step back, you'll see the new end section. And the reason why I had to step back is because we had to put in this tangent right here. The original Texas Turndown was up here. We had to put the tangent in the proper end section. And we did the same thing on the opposite side of the road. And so I can zoom in if we wanted to and get a closer look. So we have 80 maintenance stations in Utah. We're going to have 80 maintenance foremen or their assistants drive all their roads, flip forward a piece of paper, and would those pieces of paper get back to us? Maybe, maybe not. Would we have been able to organize it in one place? Probably not, knowing how difficult that is. And so now every region, every maintenance station knows where their Texas Turndowns are or their concrete slope end sections are. And they can go to that program that we have set up and they can start replacing these in a systematic process. So that's one of the tools we've developed, and I am now going to introduce Scott Jones, and he's going to tell you how we have used this information to do an analysis of shoulders. I'm just going to close this file, I guess I'm going to. Well, that's what I'm going to do. So now Scott's going to start his presentation, just so we get to it. Scott, take it away.
All right, thanks, Dan. Pleasure to be with you today. I'm going to talk about 2 projects that we are using this data that we've collected to do safety analysis. Both projects are still underway, so I'm not going to be able to show you final results or prioritized lists like Stan did, but I will show you what we're doing and how far along we are. We're going to focus today on talking about doing a systemic analysis of our shoulders, and then talk a little briefly about systemic safety with using the U.S. RAP protocol. So we have an issue in Utah on one of our two-lane rural roads, especially. These are highly used recreational routes, and you can see Monument Valley there in the picture at the bottom. We get a lot of these bike tours that like to come through our rural sections of the state and recreate. But a lot of our two-lane rural roads, as you can see from this picture, have no shoulders. And in fact, a lot of times the travelway is not even 12 feet wide. It just goes to gravel at the shoulder line. So we're conscious of needing to do a systemic analysis of the conditions of our shoulders and where we should improve and widen our shoulders. Problem is, if we did a statewide analysis of our deficiency, and we would need $2 billion to bring every shoulder in the state up to standard. And so where do we start? Obviously, that's an overwhelming need. So what we did is we started with the inventory of our shoulder widths. And here's a GIS map from our U-Plan describing from our data collection our current shoulder width. Different roadways there. We then combine that with our priority bike facilities. This was information gathered by each of our UDOT regions in cooperation with not only local governments but local bike touring groups to analyze the use of our roads for recreational bike use. We also combined our crash data, looking at bike-specific crash information as well as run-off-the-road crashes. I must tell you, this slide does not show you just run-off-the-road and bike crashes. This is a representative risk map representing all crashes. I did not have a specific map to grab today. Sorry about that. And then we also threw in there an analysis of our primary freight truck routes, recognizing that freight travel not only impacted the use of the roadway, but shoulders were a critical safety component for these larger trucks that were on the roadway. We put it all together, and as we speak, we're creating that prioritized list, much like what Stan showed you with the Texas turndowns, where we're weighting each of these factors to pick the top spots to start our systemic road shoulder widening program. So, I also wanted to mention briefly, we are using the data that we collected to feed it into a systemic safety tool created by and used and promoted by the U.S. RAP Foundation for the U.S. Roadway. Sorry, I'm getting jumbled. This is being promoted by the AAA Foundation for Traffic Safety, who is promoting the U.S. RAP protocol here in the United States. It's an offshoot of an international effort that these protocols were developed and they're being used around the world. So I showed you the risk map already for the crashes, and that primarily uses crashes to identify risk. But what I really wanted to talk just a moment about is how we're using the roadway and roadside features that were collected to do systemic safety. So here's a list of items that were collected in our data collection. That this is a representative list of categories of data that feed into the systemic safety tool. I might mention these are the type of things that can be collected through a visual inspection, but in their totality, when brought together, they paint a picture of the roadway and roadside conditions that are helping us feed into the model to develop what the U.S. RAP software called the Safer Roads Investment Plan. This is an example of an investment plan that was done for Kane County, Illinois. I'm hoping that's large enough that you could see some of it, but I'll just mention the first two prioritized list of recommended projects based on the input of all those data elements. The model outputs suggested safety projects, and what's significant about this is this is a systemic network-wide analysis of these type of treatments. So you can truly say this is my highest priority along the network for this type of safety treatment. So the first safety treatment here recommended for Kane County is center median barrier. And then the second one, interestingly enough, since we just talked about shoulder widening, is shoulder paving. And the model gives you project expense as well as benefit cost ratio and a calculation of lives saved from using safety performance functions and crash modification factors to calculate return on investment. So again, we are just signing a contract for some support to help feed our data into this model, and in the next 3 to 4 months, we look forward to having our own output from this tool. So I'm going to hand this back to Stan for a quick wrap-up, and then I think we're going to open it up to questions.
Thanks, Scott. I wanted to show you one other tool that we have. Scott and I talked quite a bit about UPlan and UDOT, and I want to show you that because it gives you an idea of the power of putting data in one location for everybody to use. So this is a public-facing website, and the URL is data.udot.utah.gov. And I am just going to show you a little bit of the functionality of this. Here is UPlan. The linear bench is a straight line diagram. I'm just going to give you a quick tour of this. And you might not be able to see precisely what I'm doing, but I am showing you all the state routes in the state of Utah right now. And we're going to find out everything there is to know about a specific state route because we've organized all our data in one place. So I clicked and I clicked state route 71 in the positive direction. It's 22.5 miles long. For this exercise, I'm just going to go from milepost 15 to milepost 22. And you might have seen this flash with all of these features. So when I talk about, we're talking about signs, guardrail, but we also have our 3-year plan, ADT, barriers, bike lanes, billboards, crash rate score. So I could find out anything there is to know about this section of roadway because we've linked all our information together. And just to give you a little bit of the functionality, we do about $200 million of preservation and rehabilitation every year in the state of Utah. That equates to about anywhere from 50 to 70 projects. They're pretty easy to do. It's basically rehabilitation of the pavement, but we're supposed to upgrade barriers, We're supposed to look at bridges. Obviously, I have to replace pavement messages, striping. We have to replace signs if they're in poor condition. And from a pavement standpoint, we want to know the square footage and if there are any rumble strips out there. So it's a pavement preservation project, but we also have to do safety. We have to fix the guardrail if there's a problem with it. We have to fix the signs if there's a problem with it. We have to put in rumble strips if there aren't any. And so there's Scott's group and my group work together to give recommendations to the regions. Then the regions have to do the design and bidding and construction. And so what we've done is we've organized it for them in one simple place where they can see all the information. So on the left-hand side, there's the state route, milepost 15 to 22, and here are all of the barriers in this section of roadway. There's only one bridge. There's this green dot right here. Here are all the pavement messages. Here's the striping. There's no rumble strips because this is an urban area of Salt Lake. It's curb and gutter. Here are all the individual signs. All these dots represent signs. And I'm moving, I should have said at the beginning, down here at the bottom, I'm moving from milepost 15 to milepost 22.4. And as I'm moving my mouse on the right-hand side, we are driving down the road in Salt Lake Valley. You can see the red dot moving. Across the top is our LRS system. These are the cross streets and the specific milepost associated with this section of roadway. So the next big thing, and this is great, this is a representation of signs. I just clicked on, there's two signs here at this place. And here are all the attributes associated with that sign, and I'll go through this slowly. It's 17.011, that's the milepost. The Murray station is responsible for that sign, the maintenance station. The condition, it's in good. There's the METCD code, the width and the height, and it's on a utility pole. It's going in the south direction. So that gives you an idea of, that sign. But here are three more, and I could do the same thing. And you can see, the station, it's in good condition, the size. Again, it's facing south. So, and what was that? It was an arrow. And let's go see it. So I can go look at it through our photo log. So the same idea is if you link all this information together in one place for everybody to see it. I'm not sure this was the sign we're looking at, but it may not have been. That's the arrow. Thank you, Scott. Scott leaned over my shoulder. That's the arrow we're talking about. So we all work together. We all collect it at once. We all look at it once. And then you can make good decisions. What we do next is we can export that. I can export it to an Excel. And so for this demonstration, I already did this because, and I'll show you that. I just clicked on that Excel spreadsheet that I loaded just before this demonstration. But what it asked for, I remember I told you this was a pavement preservation project. So it asked, are you rotomilling out 1 inch, 2 inch? What? How many inches? So I put in 2 inches right here. It said, what kind of material are you going to put in? So I said 3/4 inch. And so here's the number of tons of 3/4 inch I am going to replace on that 7-mile section of road. And it also asked, are we going to put a top wearing surface on? And I said, yes, we'll put in an open graded, and there it is. And so there's the number of tons. It asked me for the emulsion, and 269 tons of emulsion. It also asked, where are you in the state of Utah? So I said I'm in Salt Lake. So it pulled in bid items from Salt Lake. And so I'm going to show you that right here down here in the concept level report. And I'll go through this. So So we're in Region 2. Here's the date that we did this. I did this yesterday, actually. Milepost 15 to 22. You can put in what you assume the PE costs are going to be, what the expected inflation rate is, what kind of contingency do you want to have, how much is preliminary engineering going to cost. It defaults to these numbers with recommendations, as you can see. So as an example, if it's over $15 million, you probably want to have construction engineering at 6.5%, but you can overrule that. Traffic control, it defaults to 4%, but we can change that if you think it's going to be more or less. And then, so here's the cost to Rotomill. It's going to cost $500,000 to Rotomill. I know this because I'm linking this asset data to our construction data to get the real cost of rotomilling in Salt Lake for last construction season. Here's the traffic and safety cost. It's going to recommend that you do 5% of the guardrail, 5% of the signs, but you can change that. And so the cost of this project, if you wanted to know, it's $9.5 million. So we're able to do that in 5 minutes. And so I showed you the surface, but I could have shown you the barrier. And guess what? They have a Texas Turndown here. So, well, let's go look at it. Region 2 proudly says, because it's such an urban area, that they don't have any Texas Turndowns. Well, guess what? If this works, we're going to see a Texas Turndown in Region 2 in an urban area. So there it is. So, these things, all these little pieces used to get lost. Now they're all in one place. Because I had this conversation with Region 2, a very smart guy who runs their whole design program. He said they didn't have any. And guess what we do? We never would have known that unless we could link all this information. And here's the sign data. And this is the exact type of format that the contractor bids. So we itemize every item for bidding. And so the contractor sees this exact thing. It's a speed limit sign. The MUTCD code is R2-1. There's the size of that speed limit sign, 24 by 30. And here are the remarks. These have graffiti on them. These have sticker. And you can see all the signs for this section of road. Before, it just took so long to find these signs and to categorize them all that it slipped through the cracks. And it might have been done. It may not have been done. But you can see I have 300 plus signs in this section of roadway. The engineer can quickly go out with this inventory and say yes or no. I want to replace. This is faded paint sign. So they can look at it from their office and say, do we have to replace this faded sign right there? It's a noise ordinance. So it looks pretty faded to me, and we probably want to replace it as part of this construction project. So you can't overstress the importance of collecting at once, getting everybody on the same page, and then putting it all in one location for everybody to get to it. And so what I've shown you is the power of working together. There's tremendous savings. Scott's individual little safety projects or problems, I should say, are less likely to slip through the cracks. With that noise ordinance sign slipped through the cracks before because we're doing a paving project here. Signs are secondary. Well, now they shouldn't slip through the cracks. And then that website, if you wanted to go to it, you can play around with it. You can email Scott or I. If you have questions, the website is data.udot.utah.gov. So, Bob, I think Scott and I are open for any questions from the audience.
Very good, Stan. I really appreciate this presentation. I never cease to marvel at what you guys in Utah are capable of doing with this system, and really marvel at some of the programs and projects you undertake that this program really supports. I do have one quick question for you and Scott, actually. Have you been able to determine, I mean, I know what it cost, or if you could convey what it cost to collect this data and put it into the database, have you ever tried to estimate just how much this program has actually saved Utah?
Good question, Bob. Scott, jump in too. So for years, we've been hiring contractors to do pavement distress and photo log. So that cost for us is $1 million every other year. So we do that as a matter of course. But the asset part was another $1 million. And then Scott, how much you added on top of that to do the Meyer elements? You know, off the top of your head?
You know, it was only a couple $100,000 more, because once we had the economy of scale of the contractor going out, collecting the data and extracting the data, it really wasn't that much more to get the few extra data elements that we weren't already identifying to collect.
And then, Bob, you've asked the question that everybody asks. Well, we know how much it costs. What are the savings?
Yeah.
And so we have started capturing those. Scott's given me numbers, and then so the bottom line is we're up to over $1 million right now in savings from our billboard program. I could have shown you every billboard in the state of Utah now. From our pavement management system, from our safety. The last thing I showed you just now, the linear bench straight line diagram, we estimate our savings on that are going to be 4 to 8 person days per project. And I said we had somewhere about 60 to 70 projects. So what happened before, we had to do this inventory in the field. We actually had to go out to the field and had to measure the width of these roads, the number of lanes, the length of the guardrail, the height of the guardrail. And so 4 to 8 people, 1 person days, times 60 to 70. And just think of the safety ramifications. The road I showed you is a pretty busy arterial in Salt Lake, 50,000 vehicles a day. I don't know how you dodge across that road with a wheel, but I could have shown you interstate, and there we have 200,000 vehicles a day. How do you do those and be safe? And so we're up to, I think, Bob, that we're up to 1.1 million in savings.
Wow, that is phenomenal.
Annual savings of 1.1 from the various. I told you all those folks that are part of this team, and I've gotten savings from half of them so far, 1.1 per year.
Definitely be interested in following up with you guys on that. What I would like to do, our participants have been submitting questions, so I'm going to go ahead and read them, and perhaps you, Stan, and Scott can answer these. From even Brasur, did UDOT extract all the features, or did the contractor?
Contractor extracted all of them. So they drive the road, and the driving the road is the fairly easy part. It takes a couple months, 3 months, 4 months at the most. But then the first go around, it took them, I think, 18 months to extract all the information. The second time, 2014, they extracted it in. They're on the line. They can text if I tell them wrong. I think it took them 3 months to extract it. So they started in March last year. We had all the information October. So that was 6 months from beginning to end, extracting everything.
Okay. Next question is from Latanya Gilliam. Was the clear zone data stored in a separate database or manually measured and processed later after the data was collected?
The clear zone was part of the original project in 2012. They've used LiDAR to determine that clear zone, and that is stored in Pontus, and they use it as part of their analysis.
Let me specify. Dan's talking about the assets and features in the clear zone. This specific clear zone requirements. That was inserted later after we used the speed limit and ADT data combined to do a systemic database of just clear zone requirements for the roadway segment.
Oh, I answered that incorrectly. I thought we were.
I'm not sure which one they wanted either.
I was talking about bridges. Bridges, we had the clearance is the clearance of the bridge. You answered it right, Scott. And what we did is we went to the LiDAR and we measured that distance, 5.3 or 6.7, and then we added that. And then Scott helped us with the analysis. It's inside or outside the course. I hope we answered that question.
Okay. The next question is from Ross Wang. Stan, for the Excel spreadsheet you showed, did you have in-house staff to do manual recognition, manually recognize those guardrail treatments, or did you have a contractor do that for you? And how often do you update the information?
I can answer that, but I want to give Scott some time too, maybe.
I'll mention, first of all, that the contractor classified the guardrail and the end sections with the data extraction. It's probably one of the most sophisticated things we ask them to do. Our staff internally that knows guardrail and end sections can visually look at these things and just tell them, oh yeah, that's a such and such version 1 or version 2. It was probably one of the trickiest things we asked the contractor to do. But no, the contractor had identified and coded all the Texas Turndown for us.
And then another part of the question, we have a 6-year contract. We collect every other year. So they collected 2012, 2014, and we're scheduled to have them start again in 2016, approximately 13, 14 months from now.
So the spreadsheet was developed. Stan kind of referred to this whiz-bang kid we've got. He does programming inside spreadsheets. You know, the world's run by spreadsheets these days. And so it was put together, the spreadsheet was put together internally.
Okay. And from Chris Aldridge, how long did it take for the tech to record all the Texas Turndown locations? Kind of a follow-up to that first question.
So when my supervisor said, hey, they're going to go out with pencil and paper and clipboards, how quick do you think you can do this? And from beginning to end, it took longer than we thought. I thought my young millennial engineer could do this in a couple days. It took him 2 weeks. So it wasn't easy.
And that's with linking all the pictures and everything. So,
yes.
Yeah.
It's linking the pictures, it's doing the analysis, it's going into the LiDAR, measuring the distance between travelway and that obstruction, pulling in the speed limit signs, pulling in the ADT, and then we beta tested it. I know Scott and I did. So it was back and forth. So I think my supervisor promised it in a couple of days. It took us 2 weeks.
Okay, very good. Next question is from Andrew Schilling. Can you touch on the comparison of 2012 to 2014 LiDAR and imagery data and how multiple data cycles are leveraged?
Yeah, that's a great question. So the data is getting better. It is getting better because the company that does it is getting better at collecting and doing the post-processing. UDOT is getting better because we're using the data, and we're actually changing the data dictionary requirements of what's needed. And so the contractor's getting better, UDOT's getting better. It's more accurate, and then the turnaround time is improved greatly. So Scott, do you have anything to add to that?
Yeah, you know, the contractor was just out here this week talking to us, and this was a big subject for us to talk about. How do you manage an asset over time? How do you recognize that it's the same asset with multiple data collections? How do you manage that asset through a lifetime inventory management issues? I think it's fair to say that this type of data collection has traditionally been used as a snapshot in time, and now we're expecting the data to track life cycle costs and analysis of an asset, specific asset. And so this is something for the industry to take note of. This is an ongoing and a growing need for DOTs as an organization to be able to do this effectively.
So we've assigned a specific ID to each one of these features now that the contractor will track from 12 to 14 to 16. And so we're hoping that will help us manage this inventory. I mentioned over 100,000 signs and miles of guardrail. It's quite a challenge to try to manage this. So we were babes in the woods when we first started this in 12, and we've learned together with the contractor.
And I think you guys have come a remarkable distance since that beginning, but you know, I think it's effort well placed too. Next question is from Mark Fauscher. Do you have a bridge clearance program, and if so, what technology do you use to capture the information accurately, and is it included in your database?
Yeah, I tried to answer this question before, and Scott helped me out, but we do have a bridge clearance, and the data resides in Pontus. Obviously, the Structures Division is responsible for it. During the 2012 collection cycle, we were hoping that the LiDAR would be able to provide a very accurate clearance. And there's still some work to do there. When you're routing a truck and you're saying it's 16 feet 1 inch, is that plus or minus 1 inch or 2 inches? And if it's 2 inches, then to be conservative, the people who route the trucks or the structures need to be precise, and that's their biggest concern right now. I think the technology is getting better, but it's not there 100% just yet.
Okay. Next question is from Edgar Kraus. Could Stan comment on how they use the LiDAR data he mentioned earlier and how it is integrated or used by UPlan?
That's a good question. First of all, the LiDAR was used to geospatially locate all features. The LiDAR is asset-grade LiDAR. It's not design or engineering-grade LiDAR. And so what I'm talking about, it's great to locate a feature. And so point-to-point, it's very accurate, but where those points sit in XYZ, it can't be used for design. But what we have used it for is we've used it for preliminary design. We've used it in the environmental process. And we've had a couple of projects where we've experimented by setting control before the collection. We can see the control in the LiDAR, and we've rectified the point cloud. So we have used it in a couple of designs. But we think right now, because it's an asset-grade LiDAR device, it's better used for concept environmental features. But I did tell you, the clear distance from Travelway to that Texas Turndown, we use the LiDAR for that. And we think it's, point to point, it's very accurate. We didn't have to locate those points, XYZ. So when you're doing a point to point, measuring the width of the road, it's great. Is the road 12 foot wide or is it 11 and a half? You can do this with this LiDAR. And that's a question that traffic engineers and maintenance engineers always have. What's the height of that obstruction? I'm going to put an additional lane in here. Is it going to have the distance? So for those kind of what ifs, we do it great. For design, it's not there yet. We would have to use an engineering grade LiDAR, and the cost difference about $50,000 for each one of these LiDAR heads for assets, and we have 2 of them, so that's $100,000 that the contractor has on them. If we're going to use engineering grade, it's $1 million. So night and day. the difference in cost. So that's a long answer to your question. Sorry.
Let me jump in and clarify one other thing. Right now, we do not have a public-facing web viewer for the LiDAR point cloud. We do have it internally shared, and we have a 3D viewer. I know that's something the vendor is talking about providing, and we've been working on a solution to that as well. But it is kind of neat to live in that 3D world and spin the LiDAR point cloud around and interact with it. But we do not have it posted on UPlan at this point.
We have an initiative going on now. I had a project management meeting this morning where we're marrying the image and the LiDAR together so you can measure the image because the LiDAR is behind it. And we should have that up and operational the end of March. So anyway, sorry, Bob, that's a long answer.
Nope, very good answer. Next question is from Ross Wang. For all sign and pavement markings, was any retroreflectivity information collected?
I'll start with this. No, I'm going to let Scott do this one first.
So we did some experimentation. Some passes on some roads were used. A retroreflective device, collection device was used. We also tried to do some correlation between that and the signature that was returned off the LiDAR point cloud to see if the LiDAR was returning anything consistent. The short answer is no. We had not found an economical way to systemically collect retroreflectivity on all the signs.
Yeah, what we thought might have been the holy grail is we could see the return off the LiDAR, and maybe we could look at the intensity and correlate intensity to the retro. And we had a lot of companies very interested in that working with us, but couldn't prove the correlation between retro and intensity.
I would imagine you guys probably get solicited by a lot of companies wanting to test out new products.
We do. We do have a lot of opportunities.
Yeah. Want to get at least one more question in here from Matthew Haubrick. That project estimating tool is great. Did you say that that was built using linear bench, and how much work was needed to create it?
Linear, that's a good question. Linear bench is part of our UGATE initiative. And the UGATE initiative is to geospatially locate everything in one database. That was in-house over the course of several years. And did Matt ask for the cost also of that, Bob?
I believe he did, yeah.
Yeah, and Matt, I have the numbers that we gave those to Florida the other day, and I want to say it was about a $500,000 effort. But I could dig those out, and Matt, I can send those to you. That's not to be used with UPlan. UPlan is a ArcGIS Esri initiative with us and then many other state DOTs. And think of the straight line diagram as everything you want to know about a section of roadway. Just put it in the filter and push a button. As opposed to plan, which is saying, show me all the signs in the state of Utah.
Oh, okay. We are about at the end of our time here. Scott and Stan, if you guys have a few minutes, I think we've got about 2 more questions, maybe 3 more, if you want to stay on in field.
That'd be great, sure.
Okay. The next question is from one of my colleagues, Dick Albin. How are changes to the road system captured and updated after the initial data capture of the entire system?
Yeah, I'll have Scott repeat the answer, I think, right?
I just whispered in Stan's ear, yeah, that's the holy grail. Getting this system linked with our and getting our maintenance forces through the maintenance management system to make real-time updates when they do field changes, and linking this to our construction systems when a contractor builds something on the roadway is something we have. Those two components we realize is a whole in this system, and thus necessitates the continual updates with data collection, because we have not made those links yet. We've talked about how to do it, but frankly, for the way we're structured, I think that's a harder effort than what we've tackled so far.
Okay. And I do have one final question here, which is from Mark Turner. And I think he's hitting on maybe the major question of the year here. What other state DOTs have contacted UDOT about emulating the system you've developed? Actually, it's a three-parter. Are there other DOTs that you're aware of who are making similar progress? And if so, can you name them? And then just as a comment, we wish all DOTs could clone your solution here.
I think between Scott, myself, Robert Hall, Kevin Griffin, probably leaving some people out. We probably talked to almost every DOT about it.
I would imagine.
Many DOTs have asked for our RFP, and we've given them that, and they've asked for the contract, we've given them that. I know that other DOTs are using this vendor specifically to geolocate their features, their assets, and I think I can name them. I know there's Hawaii, there's Alaska, there's Tennessee, there's New Mexico, Illinois is doing some, Texas is doing some, Louisiana is doing some. So when I say Louisiana, I know they're doing outdoor advertising with this concept. And I think Illinois is doing bridge cleaners. Hopefully I'm not misspeaking there. But the first set that I talked about are doing the complete inventory like we are. Alaska, Hawaii, Tennessee, New Mexico, Nevada. Hopefully I'm not leaving anybody out. I apologize if I have. And there are many DOTs that are starting this initiative in one form or fashion across the country of linking all of their information in one place to make not only decisions based on engineering judgment and institutional knowledge, but data. And I can name many DOTs that are in this. I hate to mention names because I'm going to leave somebody out, but I know North Carolina is way ahead on this. Colorado is. Iowa is making great progress. In New York State and West Virginia, the list goes on and on and on.
Yeah.
So, I don't want to. Yeah, there's a lot of credit. A lot of people deserve a lot of credit.
Okay. Well, that brings us to the end of the questions, and I would just like to take this opportunity to thank Stan, you, and Scott for taking your time this afternoon to go ahead and kind of walk us through this, what you guys have got and how you're using it, because again, it never ceases to amaze me. I learn something new every time I hear you guys speak. So with that, again, very much thank you to both of you, and if anyone has any questions, they can contact you guys at UDOT, I assume, correct?
Yes, they can. That would be fine. We'd be happy to talk with anybody.
Excellent. Okay, well, that will conclude our webinar for today, and my thanks to all the participants, and again, special thanks to Scott and Stan. So everybody have a good afternoon, and there'll be 2 more coming up on this topic from GTMA. So thank you.